What if a house could just disappear into the landscape? And then what if that same house could reappear totally unfazed after a Category 5 hurricane? I know, it sounds a little like science fiction, but we're about to dive into a design that's trying to do exactly that. It's a brand new type of dome home that brings together some seriously futuristic looks with some truly impressive strength. Just take a look at this thing. It's called the Invisible Dome, and, well, you can see why. It almost looks like it's melting into its surroundings, perfectly reflecting the trees, the sky, everything. It's a building that's somehow both there and not there at the exact same time.
You know, you have to wonder, is this just a cool concept, a piece of art, or is it a real, actual, livable home? That's really the big question, right? Because it's one thing to look incredible, but it's a whole other thing to actually function as a house.
So how does it pull off this invisible look? Well, that incredible mirrored exterior is actually a customizable finish. The whole idea is to reflect the environment around it, so the building just becomes part of the landscape. It doesn't matter if it's a forest, a snowy mountain, or a desert. It's a true architectural chameleon.
Okay, so let's peel back that reflective layer for a second and see what's really going on inside. Because behind that futuristic facade is a surprisingly practical and, honestly, very stylish living space. And here you go. On the left, you see this sleek, modern interior, and on the right, you can see the floor plan that makes it all happen. In a pretty compact 30 square meters, that's about 320 square feet, they've managed to fit a kitchen, a full bathroom, a living area, and a bedroom. It's a complete home, all packed into a dome that's just over 6 meters in diameter.
But what happens if you need more space? Well, this isn't just some one-off pod. The entire system is actually designed to be modular. A single dome like this, that's just the starting point.
The concept is just beautifully simple. You start with one core unit. Then you can add these tunnel-like sections to stretch it out. And from there, you can actually link multiple domes together to create much larger, more complex living spaces.
This right here is your fundamental building block. This is the standard Mars dome. Everything else just grows from this.
And here's the secret sauce for expansion. These modular sections can literally be inserted between the two ends of a dome, effectively stretching the home to create more room inside. You could add one, you could add two, however many you need to get the exact length you're looking for.
And this shot, wow. This just perfectly illustrates the ultimate potential. By linking these extended domes, you can create these amazing U-shaped communities with shared courtyards in the middle. It scales all the way from a tiny home for one person to a whole multi-unit complex, and it's all using the same core parts.
Okay, so we know the design is clever and the look is absolutely stunning. But we started this with a pretty bold claim, that this thing can survive a hurricane. Now, we all know that domes are naturally one of the strongest shapes in architecture. They distribute stress really evenly. But let's move from theory to some serious engineering and see if this specific dome can actually back up the talk.
I mean, this is the most important question, isn't it? A beautiful home is pretty useless if it gets blown away by the first big storm that comes along. So for real, how tough is it?
The specs here are, well, they're pretty staggering. It's engineered to handle winds of about 180 miles per hour. We're talking a powerful Category 5 hurricane. It can take on heavy snow loads and even a grade 10 earthquake. And it's built for these wild temperature swings, from a freezing -50°C all the way up to a scorching +50. All that strength comes from a 60mm thick wall, which is basically a sandwich of fiber-reinforced plastic and polyurethane insulation.
Oh, and get this, the windows are not your standard glass. Nope, they're made from polycarbonate that is 12 times harder than toughened glass. To give you some perspective, that's the same material they use for the windscreens on helicopters. Yeah, so you're probably not going to need to board up these windows.
And look, these numbers aren't just some marketing team pulling them out of thin air. They come from a very detailed structural verification report, where engineers put this design through its paces using some incredibly sophisticated software to simulate real-world forces.
So to really test this thing, engineers basically broke its surface down into all these different zones, which you can see in these diagrams. They then hit it with simulated wind pressure from every angle you can think of, just trying to find a weak point. The dome's aerodynamic shape is meant to let wind flow right over it, and this is the hard data that shows it actually works.
So, after all the simulations, all the crazy calculations, and all the pressure tests, what was the conclusion? What did they find? Well, the numbers don't lie.
The most important part is sitting right here in this table.
Just look at the massive difference between the maximum observed force the dome experienced in the tests and the allowable limit it's built to handle. Let's take compression stress, for example. The dome only experienced about half a megapascal of force, but it's designed to handle 193. In every single test, the actual stress was just a tiny, tiny fraction of what the structure can safely take. It wasn't even breaking a sweat.
You know, the full engineering report is filled with all sorts of complex charts and data, but the final verdict couldn't be simpler. That column of OKs on the right, that tells the whole story. The dome has the strength to back up its wild design. It passed. Period.
So, what are the big takeaways here? Well, we've seen a design that is visually stunning, one that can literally disappear into nature. We've seen that inside, it's a fully functional home. We've seen that it's a modular system that can grow from just one little unit into an entire community. And most importantly, we've seen the proof that it's an incredibly resilient structure, engineered to survive some of the most extreme weather this planet can throw at it. It really leaves you with a final thought, doesn't it? As we all look for new ways to build in a world with more extreme weather and constantly changing housing needs, is this the direction we should be looking? Could these beautiful, adaptable, and unbelievably tough structures like this dome, could they be the shape of things to come?